So we have to now address the fact that there are some metals with more than one charge. For example, the practice problem I just gave you with magnesium nitride. If you look at your periodic table, magnesium is number 12, directly above the magnesium, you see a tiny little number 2. That means magnesium is a +2 charge. Now you wrote that really big above the column heading last time because every alkaline earth metal is a +2 charge. Recall, if they lose those 2 valence electrons, they now are a full outer shell octet. They're stable. If you look at iron, for example, you don't see one tiny little number above it. You see probably 2, right? A 3 and a 2. Maybe the 3 is in bold, but the 2 isn't. That means iron has more than one possible charge when it's an ion. That's what that little small number directly above the symbol represents for metals. So before I continue on talking about this any further, let's just make sure we address something here. Why don't you look at sulfur on your periodic table? Do you see several little numbers above sulfur? Ignore them. For the non-metals, so ladies and gentlemen, look over here. Non-metals, things to the right of the staircase, only pay attention to the big charges that you wrote above the column. The reason why is when you look at the key on your periodic table, those tiny little numbers are called oxidation states. Oxidation states fall into 2 categories. One is their ionic charge, which is what we're dealing with right now, which works great for metals. But oxidation states also plays a role in non-metal bonding or covalent bonding, which we do not want to confuse you with right now. So, when we look at the things on the right side of the staircase with the negative charges, their charge is only one option, these things right here. Okay? However, for the metals, the little numbers do make a difference. What we need to go over today, then, is a way to show these things. Because I'm going to pass this around right now, so please be mindful of the fact that these are chemicals, so we're not going to touch or taste or anything like that. But I have here 2 different versions of copper combined with chlorine. They look different, even though it's the same 2 elements, copper and chlorine. For those of you who haven't had a chance to look at it yet, I'm going to show the safety data sheets for the 2 of them up here. For one of them, it gives a skull and the crossbones. It's toxic if swallowed. For the other version of the copper and chlorine, it gives the exclamation mark. It's harmful if swallowed. Same 2 elements, yet they behave differently. Not only do they, danger-wise, are different, they do react differently as well. Notice how these are written. Copper, Roman numeral 1 chloride. Copper, Roman numeral 2 chloride. If you look at your periodic table, for copper, which is element 29, you see 2 little numbers directly above the Cu. You see a 1 and you see a 2. That means copper can exist as a +1 charge, or copper can exist as a +2 charge. The tricky part about this is we need to be able to express which one are we working with. Because if we can't, you don't know if you're dealing with something that's toxic or something that's just harmful. Which is why we need to use Roman numerals to represent the charges of some of these metals. What I'd like you to do, because not everyone grew up with an old clock, is on your periodic table. You know how we've been writing on it every single day? We're going to do some more writing on it right now. You can do this on the very bottom, the very top, wherever you like. We need to know Roman numerals 1 through 8. I wrote them up on the whiteboard. I'd like you to write them on your periodic table somewhere right now. That way, when we start using Roman numerals, you don't have to remember, oh, which one is this? Which one's that? So I mean, it's pretty straightforward for the first three. One line down or an I is for the number 1. Same for number 2 and 3 where there's 3 lines down. However, the number 4 is a IV. V is for 5. They put the 1 before to show that it's 1 prior to 5. VI then is 6. We only need to go up to 8 because on our periodic table, there's nothing that I'm aware of that has a charge greater than a +8. Even that is unusual. Osmium, number 76, has a +8. Ruthenium does as well. But most things will not have that charge, so we only need to know up to 8. Another way to think about why we have to do what we're about to do. I don't know if you're aware of it, but last year, there were 2 Haley Christensens in this school. So if the office made an announcement that said, Haley Christensen, come to the office because your house burned down, you'd have 2 people freaking out. But only one of them would have had the issue because they weren't even related. That's why when you have 2 people with the exact same name in this building, which we do occasionally, I just knew Haley. Actually, I think I knew both Haleys. That's why we would use middle initials. Haley C. Christensen. Now only one of us is going to come to the office. Haley R. Christensen. Okay, only one of us is going to come to the office. So when you have some ionic compounds, metal and nonmetal, that have more than one option, copper 1 chloride, copper 2 chloride, we need to differentiate between them. However, we are not going to change what I taught you last class. Remember the problem that started off class? Magnesium nitride? I'm not telling you a Roman numeral or whatever in between the two, because there's only one version of magnesium, a +2 charge. It only has one tiny number directly above it. But if there's more than one version, we have to use the Roman numeral. So, for example, there's only one Andrew Wilson in this school, right? As far as he knows. So there'd be no reason for them on the announcements today. Did they actually do this or tomorrow, rather? I don't know if they'll do this in announcements tomorrow, but they're not going to use Andrew's middle initial when they say happy birthday to him. It's your birthday tomorrow, right? Well, happy birthday tomorrow. So you don't need to do it. Why in the world would they use his middle initial if it's not necessary? You only do if it's necessary. What I taught you last class was the simplest type of naming. A metal with only one charge. Give me the first and last name of that individual. Done. Andrew Wilson. However, if there's more than one individual with that name, there's more than one Haley Christensen, we have to use the middle initial to represent that. That's what we're going over today, is some metals, we have to be a little bit more specific with their naming. You picked up on the way in a worksheet that was titled Nomenclature for Ionic Binary Compounds number 2. You can have that out. This is going to explain what we have to do with this. Now there is a list of rules at the top, just like the last how-to sheet I gave you did. I'm going to skip those for now. I want to go straight to the first practice problem, where it gives me the formula of MnO3. In this class, we have to either be given a formula and know how to write the written name, or be given the written name and know how to write the formula. So we have to do either or. So I want to start with this problem right here. If I give you the formula, I need you to tell me the name of MnO3. First, what's the name of Mn? Manganese, right? Here's my suggestion. Leave a little space after you write manganese. O is oxygen, but we don't call it oxygen when it's in a compound. We call it oxide. So leave a little space. Oxide. Now, find manganese on your periodic table. If there's only one little number directly above the metal, the Mn, we'd be done. Because this is what we taught you last class. Write the metal, write the non-metal. That's why I suggest for any naming that we're about to do in class, write the metal, write the non-metal, but leave a little space. If you don't need to write a Roman numeral because there's only one charge, you are done. There's only one Andrew Wilson. We don't need to refer to him with his middle initial. However, I bet you see more than one little number above the Mn, don't you? Okay. So now we have to determine what Roman numeral to put in there. It's pretty common that we put that Roman numeral in parentheses just to kind of separate it out, especially since we have a lot of Roman numerals that look like I's. We do have a non-metal that starts with an I as well, iodine. So, this used to be the easy thing. I give you the formula, you give me the name. Metal, non-metal, let's move on. Many of us got many wrong on that first top part of the homework. This is now the tricky part for this class. We have to figure out the charge of the manganese. And what does it say above it, like a 2, a 3, a 4, a 6, and a 7? There's a lot of possibilities there. So, the way we figure out the manganese charge is by knowing what the non-metal is. Because in an ionic compound, charges balance out. What's the charge on oxygen? -2. If I have 3 oxygens, I would take -2 times 3, means my total negative is a -6. Are we okay with that? MnO3 means I have 3 oxygens. And I know that each oxygen is a -2. When the formula is MnO3, that means I only have 1 Mn. That 1 Mn must balance out these 3 oxygens, because in an ionic compound, charges balance out. What must be the charge of manganese? 6, right? So, put the Roman numeral 6 in the parentheses. On your own right now, take a minute to try to do the other 4 problems on this first column. My suggestion, again, is step 1, write down the metal, leave a space, write down the non-metal. Step 2, look at your periodic table. Determine if there's more than one charge. Because if there isn't, you're already done. That's what we taught you last class. But if there is, you figure out the charge of the metal by knowing the non-metal. The Roman numeral stands for the charge on the metal, not how many there is, which is the most common mistake we have with this. Copper's a -2. I'm sorry, oxygen's a -2, right? And there's only one of them, so that means my total negative charge in the second one is a -2. I have 2 coppers to balance that out, however. So again, think about it as here's an oxygen, here's a copper, here's a copper. When you do the Roman numeral, you are representing for each copper what is their charge. Copper's a +1. Because if I have 2 of them, each of them being a +1 would get me to a total of +2. So you almost have to do a little division here then, of the -2 divided by the 2. Tell me it's a +1. So this should have been copper 1 oxide for the second problem. Again, most common mistake is students are going to say the Roman numeral stands for how many there are, because there's 2 they want to call it copper 2. That's not the case. Each individual copper is a +1. CaF2 is calcium fluoride. Mn2O3, a little trickier with the math on this one. This is going to end up being manganese 3 oxide. And this one you can almost do the opposite across the drop.
What's like calcium one? Just calcium fluoride.
Yeah, you don't use the Roman numeral 2 for calcium because calcium only has one possible charge. Lastly, PdCl4 is palladium 4 chloride. I'm going to do the first 2 problems on the right-hand side with you and then give you a chance to do the last 3 on there. And then we're going to have a little time to just kind of work. If I give you the written name, I need the formula. To do that, you should know the symbol and charge. Eric, what's the symbol and charge for calcium?
Ca2.
Yep, calcium is a +2. Isaac, what's oxygen's symbol and charge? They already balance out, right? So, CaO is the answer for calcium oxide. The next problem on your sheet is tin 4 chloride. Jaden, what is the symbol for tin? Sn. And I bet you see more than one little number above it, right? A 2 and a 4? But then, which version is it in this compound? How am I supposed to know? Joey?
It's 4 because
the Roman numeral tells you what it is. That's the entire point of this. So Sn is a +4. James, you know chloride's symbol and charge? Cl -1. Marina, bring it home. What's the formula for tin 4 chloride? I didn't hear you clearly there. Sn? How many chlorides do we need? And you can cross and drop. Sn. Yeah, SnCl4.